Disproof by counterexample. When proving a statement, we must show that it is true for every possible case, or at least we should know which cases it's true for and which cases it is not. If there are only finite cases, we can show that all of the cases work. This is known as proof by exhaustion, which we'll be looking at shortly. This can be used when there are infinite numbers to check, but they can be categorized into finite cases. Often, we must use a method that enables us to show that the statement is true for infinite numbers of cases. To prove something untrue, however, all we need is one case that does not work. Such a case is known as a counterexample. A good example of this is the case of Mersenne primes. Marin Mersenne, who lived from 1588 to 1648, suggested that Mn, known as the Mersenne numbers, is equal to 2n minus 1, would always produce prime numbers provided that n itself is prime. For reference, there is no formula known that only produces prime numbers. So let's check some of these Mersenne primes. n2 means substituting 2 in for n, so that would be equal to 2 squared take away 1, which gives us 3, and we know that 3 is prime. m3, substituting 3 for m, gives us 2 cubed take away 1, which is 7. m5 is 2 to the 5 take away 1, which is 31. So far all primes. m7 is 2 to the 7 take away 1. That's 127, and you can check that is prime. When we get to m11, however, 2 to the 11 take away 1 is 2047, and that can be factorized as 23 times 89. So 2047 has 1, 23, 89 and 2047 at the very least as its factors. It has more than 2 factors, so it's not prime. And this disproves what Mersenne said. This formula does not always produce prime numbers when n is prime.